Hello! In this video I'm going to be showing you how to create these trees using Cinema 4D and Python. Now just to forewarn you, the methods to generate these trees didn't factor in animation. However, you can animate them, it's just that you'll lose the benefits of generative design because you're going to have to manually apply the animation and all the rigging and likely rework some of the geometry. But just to demonstrate it can be done, as I've done a little sample here with some organic structures, which I like to think of as some sort of neon funky coral stuff. And each of the limbs are rigged and we've got some hair dynamics going on for these little strands here. So they can be animated, it's just from experience this took way longer than it should have to animate, and the viewport was struggling because I couldn't use multi-instances in this case because of how much was being restructured and so on and so forth. But if you can find a better way or a more efficient way of animating these things, then go for it. You know, if you can just get away with a simple deformer, great, but just thought I'd put that out there before you invest in it. Before I get started, I want to make sure that I credit the reference that inspired me to do this in the first place, mainly because without it, I wouldn't have even been able to start this project. And the second reason, because they'll be able to provide with much more detail when it comes to the coding aspects of how things work. So the video I'm referring to was by someone named Coding Cassowary. I'll post a link to it in the description below, but it is basically covering generative art and more specifically fractal trees. And within that they use the Turtle module within Python to create fractal trees on a 2D plane, and now after watching that I thought maybe I could do something similar but in 3D. So I'll refer to that at points, but yeah, that thought it was worth crediting them because otherwise, you know, it'd feel wrong to claim this as entirely my own. Anyway, let's get started. First thing we want is the script manager, and I'm just going to dock this on the side here, and I'll get the first scripts. There'll be 3 scripts. First 2 are the most important ones, and this first one should be familiar if you've watched the reference which I mentioned earlier. Now for those who don't know and just want a rough overview of what's going on, basically what we're doing is we're creating a null and naming its root. So it's basically this, and then inserting it into the object manager. So we've basically created a root null. Then we've got a branch ID, which is equal to 1. Now this variable isn't doing anything yet, which is just something we're going to be using later on. And then we call this grow function and pass in a bunch of variables here. And here's a grow function here. What we're passing through is the new null, which is this root which we created, the branch ID, which we got as 1. Then we've got the length, which we've got up here as 150, which is referring to 150 centimeters. Decrease, which is 0.8, which we're going to be multiplying the length against whenever we iterate through creating branches to ensure the branches get smaller and smaller. And then we've got the angles to ensure the branches don't grow in the same direction. And then a bit of noise for random variation, which I've not actually used in this, but this was referring to the initial reference that I used. I ended up creating different forms of randomization, but that's just there because it was used in the original reference. In the grow function, we start off with checking if the length of the branch will be greater than 10 centimeters or not. If it is, then we can grow more branches. If it's not, then it will stop growing branches. This is to ensure that we don't grow an infinite amount of branches. So the first step in this is we create a variable called old null, which stores in the new null. So basically what we're doing is keeping this root null here as a reference. This is the first iteration, so in this case this old null will be storing this root null. Then after that we're creating another null, and then giving it the name of the branch ID, which is 1. So I'm just going to do that, basically doing that, and then we're inputting the angles for the bank and heading, which would be these, but in our case we're inputting zeros, so we just set these as 0, and then we change the relative y position to the length, which is 150, or I should say increasing it by 150, and then we place it as a child of the old null, like so. So that's basically the first iteration here so far. Then we create a new variable called new length, which takes the length which we've brought in and decrease it, basically multiply it by 0.8, so the next iteration will have a smaller branch. And then here we're setting the angles for the next iteration, which we've got angle B1 for the first branch, which will go in one direction, and then we've got angle B2, which will be for the second branch, which will go in the opposite direction, which is why we've got a negative here on this one. Now we have introduced a bit of randomization in each of these, so they're not perfectly symmetrical. So one might be like, will be close to being vertical, and then one could be completely sideways. That wasn't the best way of describing it, but hopefully you get what I mean. And then we've got angle H here, which will add more variation in the heading, so we don't end up with just a flat tree. We end up with a bit of depth to it. And then we increase the branch ID by 1, so we know the next branch tier will be increased, so when we're checking for the IDs we know which tier that branch is referring to. And then we grow 2 branches, with the difference being one using angle B1 and the other using angle B2. So we grow 1 and we grow 2. And then we set the null back to its original position. Now this bit is referring to how the turtle module worked in the initial reference. I couldn't quite wrap my head around why it is needed, but it was needed because otherwise you just end up with a long stream of branches rather than actually branching off. Anyway, you'll see it in the reference if you watch it. So enough waffling, let's see it in action. Just going to delete this and then hit execute. And as you can see, we end up with something resembling a treetop, or at least a cloud of nulls which resembles a tree. It does lag a little bit, so if I select these, it does appear in the viewport. And as you can see, we've got the first branch, and then it splits off into more and more. So here we go. It goes all the way up to 13 branches, so all the depth of 13. So we've got a lot of branches to go through. So now we've got this information, what we need to do is connect the dots. And we can't just throw in a trace for objects because it won't know which order the dots need to connect in. So you're going to need a tracer object for each individual branch. And there's going to be roughly 4,000 branches. I mean, I've used this formula before, and usually we get around 4,000 branches. So yeah, creating 4,000 tracer objects is going to be very tedious. So I've created a second script. Now this one I've made entirely by myself, so feel free to use this if you want to, because it's going to be painful without it if you're going to be following along with this. And what it's going to do is it's going to trim off these duplicate end bits. So where we've got 2 of the same null, it's just going to delete the excess one. And then it's going to rename this root null to say that it's done that, it's trimmed them, so I know not to do that again. And then on top of that, it's going to create a tracer object for each individual path. Now the most important part of this is that the tracer objects will be disabled, because if they're all enabled and we have 4,000 tracer objects, the machine's just going to crash. So yeah, let's see this in action. Just going to hit execute. And here we go, we've got 4,096 branches. And you can see the root null says it's trimmed, and if we scroll down, we can see it's removed the excess endpoint and then just named the actual endpoint with the suffix of endpoint. So I now know that it's all worked. So what do we do now? Well, just check things have worked, and you can see we've got some branches here. And in the settings for these, I've used B-spline and just kept it as adaptive, just so we get a nice curves with the branches, so it's not so rigid. Do a few more, and then scroll up, maybe select some of these, see what these look like. you can see it's already lagging a bit with very few traces enabled, but you can see it's doing its job. It's connecting the dots essentially. So what I'm going to do now is disable all these for a moment, and then I'm just going to scroll through quickly, make sure. Yeah. What I'm going to do is introduce my third script, which is simply called enable and select previous 10 traces. So I'm going to select this and then I'm going to hit execute. And what it's done is selected the previous 10 traces and then just turned them on. The next step with this is to connect objects and delete, because all I need is a spline. I don't need trace for objects, I just needed that to be generated. Now it's been generated, I can just make it editable. The thing is, I'm going to have to do this in steps because I can't enable them all at once. So I'm going to take this script here, place it here, so I can just press this button. And now instead of right clicking and doing connect objects and delete, what I can do is go into customize palettes, try and find the connect objects and delete, and I can either drop it on here so I can just press the button, or I can assign a hotkey, which I've assigned the hash key as the hotkey for that feature. So I'm just going to press this button first so you can see that works, and then I'm going to go back to this, select the next lot, then just hit the hash key. I found this to be a lot more efficient when it comes to doing this. Now you're probably wondering, with all this automation, why am I doing this manually? Like, this is probably the thing you want to be automating. The problem I had was that if I was to do this too quickly, like through a script for example, it wouldn't know whether it's connecting splines or polygons, and there's a risk of creating a polygon object without any information in it. So basically I'd end up with an empty branch, there won't be any information in it. So I've ended up opting to do this manually. And even if I were to do this a little bit too quick, those splines could end up becoming polygon objects. Anyway, I'll probably pause the video at this point and then just speed it up because we're just going to be here for a very long time. Okay, and the last bunch. Select all those. Connect. So we've created the splines for the branches. Okay, so the next step, don't need the scripts manager anymore. What we want to do, and this is quite an important part, is select all of the branches, right click, and then do connect object. Not connect and delete, do connect object, so we get a copy of all those splines in one spline. We're going to need this later. So for now I'm just going to turn that off, and then what we need to do is create the geometry for these branches. So I'm going to select this top one, and select all these, hold Alt, and select sweep. I'm going to turn these off for now, just in case. It should be okay, but you never know. Now, whilst we've still got these selected, I'm going to hold Shift and create a circle. So we now have circles as children of these sweeps. I'm going to set the radius to about 40. You want the radius to be matching the diameter of, the radius of the trunk. So I'm going to set this to 40. I think that's a good setting to have. And then I'm going to fold all. And then I'm going to select a few sweeps, see how it looks. Right, okay, so that's not looking too great. Reduce the scale, and it's reducing the wrong side. So what I'm going to do is turn off all the sweeps. Search for the branches again. Select them all, including that top one. Then go to points, and I'm just going to reverse sequence. Okay, so it knows which end is actually the end. So if we turn these on, select all these, turn down the end scale, and there we go. It's looking a bit chunky there, I don't really like that, so I'm going to do custom scaling instead. So go here, adjust that, and maybe pull that down a bit, maybe do something like that. This is all subjective at this stage, you can create whatever you want. I'm just going to go with something like this. And then I'm going to copy that and paste it across all of the others. Now, yeah, I'm just going to turn them all on, I think. I think it should be okay with this amount. So I'll stop there and see how we're doing. It seems alright. Carry on. Now, depending on your machine, this might not be a wise idea, but I think mine can cope with it. Okay, so we've got the branches as geometry. Now, the next issue is that we've got a lot of intersecting geometry here, which is not going to be good when it comes to texturing and so on. So what we need to do is merge it all together. Now, the first thing we want to do is select all these and connect the objects, but that won't solve the intersecting, but bear with me. So I'm going to connect objects, and oh, I should have done connect and delete. Getting muddled up, may as well delete them. So we've got an object there, which is a copy of all those merged together, and then we want to go into. Actually, I'm going to save it first. I think. One moment. I'm just going to pause it and then save. Okay, I'm back. Just wanted to make sure that everything is okay. Going to hold Alt and select volume builder, and then volume mesher. I always get those in the wrong order. Got it right this time. And then I'm going to set the voxel size down to about 2, I think. I'm just having to wait for the volume builder down here to calculate. I've got quite a few things running at the same time, so it may take a little bit of time. Okay, let's have a look. Okay, so what this is going to do is merge all that geometry together. That's what we want. Now, we kind of want some detail in this, but maybe not too much. Right, I'm going to turn off those branches as well. I'm going to hide the nulls. Okay, so this looks awful. So I'm going to introduce some smoothing. I'm going to go with mean, I think. Actually, try. That might be too much. Let's increase iterations. Well, this could work actually. Let's turn down the voxel size to 1. I wouldn't worry too much about the density at this stage either. So long as your PC can like generate it, then you're fine, because what we're going to do is reduce the density of the polygons later on. Okay, this is looking okay. It's just those straggly bits I don't like. I do one more iteration. Might be too much. Yeah, things are breaking there. I'll do something like that, I think. I know there's a bit floating here, but we can just delete that. Okay, I'm going to say I'm happy with this. It seems alright. Now what we do is current state to object. And now we can get rid of this pretty much. What I'm going to do is go to polygon mode. You can see there's a lot of polygons. I'm going to, instead of just select it, I'm going to go do UF to select this main body, then do UI, because there could be other bits which I just can't see. I'm just going to delete those. Okay. So now I've got this. The next step is to reduce the amount of polygons. So we're going to get a remesh. Holding Alt, again, so it makes it the parent of the object. Now it's already generating something, but what I want is to reduce the density, so I'm going to let it restart again. Wait for it to finish remeshing. Fingers crossed it does a good job. And there we go. Now when we look at the polygons, nice and clean. So we've got some decent geometry, and then yeah, we've got the branches. So now you're probably thinking, what about the end branches which you just spent ages trying to create? That's where that spline comes in. Now, because these are going to be so incredibly thin, we're going to be using the Redshift object tag to turn them into hairs, essentially. So what we're going to do is, first of all, make this editable so we don't need to look at this anymore. I'll do current state to object. There we go. So we've got the geometry, we've got the branches. What I'm going to do is right click, Redshift object. Then you can do hair strands or whatever you want to use, but I'm going to just do hair strands. And then let's see how this looks, if it works. There we go. So this is what we're getting so far. So we're missing the end bits now. So what we want to do for that is create a matrix object, which will create all those boxes there. Go to object, drag in that branch, and we want to set the count to 1. And oh, they all gone to the bottom. That's very bizarre. You can just offset them to the end if you want. That works as well. Strange, I thought it would have automatically put them on the ends since we changed the point order before, but there you go. Now we've done that, we want another Redshift object tag. In the particles, set them to whatever you want. If you've got leaves made, you can use custom objects and use that. I'm just going to use optimized spheres. See how this looks. They look very tiny, so I'm just going to turn this up to about 4 or something like that. There you go. That's essentially how we created the trees. So if you were to come back to this, basically used that to create trees here. So you got the mesh, you got the splines for the end branches, and then for any which I wanted leaves to be on, I created a matrix and then put the materials on. So we ended up with these nice miniature looking trees. And obviously you can change the leaves to whatever you want, but that's basically how they were made. If you have any questions, feel free to put them in the comments. If you need any help with scripting, I can try and answer some questions, but if you want to know more about generative design and fractal trees, I would recommend looking at the source reference which I used rather than asking me, because I myself am learning these things as well. So yeah, I hope this has helped in some way, and I may cover that, how to animate these, in another video. May not, I don't know. I don't know if it's worth your time or mine. But yeah, hope you enjoyed it, and I'll see you in the next one.